Doctori, tutto a posto? Welcome back to a new video about Sane C++ libraries. So what is this project? It's a project you can find on GitHub if you search for Sane C++ libraries, and it's a set of platform abstraction libraries for macOS, Windows, and Linux written in C++, as you can imagine from the name. It focuses on fast compile times, being bloat-free, simple and readable, so there is no complex use of C++ involved. It's easy to integrate. There is no use of C++ standard library or exceptions, and there are no third-party dependencies. So now let's try to dive into the specifics of what we are going to show today, or to try to do today. The problem I'm trying to solve is the following. There is this async library, more specifically it's called SC, Sane C++ async library. That is an asynchronous I/O library like libuvu, or if you want boost asio, hopefully a little bit more clear than that. But the point is, this library, just like every other evented I/O library, has the concept of an event loop that you can create, and creates the kernel objects that hold a queue of operations inside the operating system. Then you can create a series of objects, which can be reading from a file, or reading the event of a process that is being disposed, this kind of things. Once you start any of these operations, then you need to run the event loop. So in that case, the event loop takes, let's say, ownership in a blocking way of the current thread. So you typically run the loop until there are no more events to pop from the event loop itself, or the program is marked to be closed because, I don't know, it's a program and receives a specific message, and you decide to shut down the program. So what I'm going to do is trying to split this runOnce method, which is the main one you're using, or the run, which is just a loop, an infinite loop over a runOnce, into three separate methods that are doing the following. The first method should be sending the queued events, actually the queued requests, to the event loop. Another one should be the blocking call that is waiting for the kernel to provide the readiness state of any of these events. So to tell, okay, yes, this request has been fulfilled. So that this read from file, now it's available to you and you can read the contents. And then there is the third method, which would be calling the callbacks that have been registered for each request. How are we going to do that? Let's try to understand how the current runOnce works. So the current runOnce works like this. There is this runStep that has this parameter, but we are not interested in what this parameter is doing. It's detail we're not interested in right now. So we are staging the submissions, and staging the submissions means just taking all of the async requests that have been pushed into this submission queue and making them active. So assuming there was no error here, we do early exit if there is no active handle. So we have been asked to run an event loop step, but there is no actual handle that we need to look for. There is nothing we have been registering in the kernel, so we can safely exit. But if that's not the case, then yes, we sync with the kernel. Sync means we basically exchange or write the asynchronous requests that have been submitted. And we also, in the same step, wait for new asynchronous requests to be fulfilled. Once we do that, we execute timers for backends that are not able to handle timers natively, so we need to emulate them, which means every backend with the exception of IOU ring. And then we execute the completions, which are the callbacks registered with every async object. There are some other details, but we don't want to go into that, like the manual completions and the thread pool completions, but conceptually it's all the same thing. Now, So the first step would be splitting basically this method into this section, or maybe this section, this other section, and this should be this third section. It looks like an easy job, but it's not so easy because, as you can see, there is this kernel events object, which is specific for every backend that has a lot of specific operating system specific data structures that it's not so easy to expose, because we have some rules in this project like do not expose internals, OS specific internals into public headers. So we need to come up with something different. So I'm going to create, let's say, a struct. Let's call it AsyncKernelEvents. So this struct should be holding I think just a little bit of memory where we want our events, native events, to be written to. So let's go, yeah, here should be okay. Struct, so let's see, AsyncKernelEvents. I think I can do a span of const to uint 8t memory, and I guess I will have some private variables. So my first method would be submit, how do I call it? Stage submissions, submit requests. I don't know. And this is taking an AsyncKernelEvents object. Then I can have blockingPoll, and then I can have runCompletions. Maybe I will change the name of these ones, but I guess for now they should be good. Let's try to implement them. Oh, these are defined into the internal class. So yeah, I should probably be defining them in the same way also into the internal class. This is where basically we are hiding all of the details, implementation details, so they are not visible to the outside world. Okay, yes, this should be okay. Now, can I just return result true? And let's go by implementing each single one of them. Maybe I can remove this. Yeah, let's try with the first one. For now, I'll just copy and paste the implementation code. So let's see, this is the first one. So we want to be just submitting the request, so running the stage submission, but we want to be passing this AsyncKernelEvents that has the memory we need to write to, because we need to persist the memory of kernel events. That's the point. Maybe it was not clear before, but the issue is this kernel events object is like an ephemeral object that has the kernel events, and I need to find a way to persist it for let's say the duration of these 3 calls. So I need the caller to provide me a location of memory where I can write to and persist these objects. So kernel events, of course, we don't have anything that matches the signature. On Apple, that's the overload that gets called, so I can say sync, it's called kernel events, yes, async kernel events. Now I probably should do it also here. Yeah, we have, well, I'll just pass like a bogus one for now. Then I'll fix it. AsyncKernelEvents. Now we have unused parameters. I think I can do the following. I can replace this k-event events into a pointer, and let's say, yeah, I should probably remove the memset. So memset should go here, which at this point would be just memsetting the AsyncKernelEvents memory data with 0, AsyncKernelEvents memory size in bytes, should be safe. Yeah, maybe wrapping this into a method so we don't just randomly memset somewhere with the risk of doing something wrong could be better, but for now we're just prototyping this stuff. I can say now events is reinterpret cast, yeah, type of events, and we take AsyncKernelEvents memory data. So we just cast the data buffer that we have been provided. We need to be careful with the alignment here. So maybe a check on the alignment too will be great to be adding. Yeah, maybe to do add check for alignment. And how many of them do we have? So before we had like a hard-coded number, but now this becomes just yeah, becomes maybe a constant, but it's a runtime number. So let's say total number of events. How many events can we fit here? We can fit exactly AsyncKernelEvents memory size in bytes divided by size of events of a single event. Yeah, so this is the total number of events that we are going to be able to use inside this kernel events. Yes, and also this new events counter, which is tracking the number of events being pulled from the queue, now needs to be stored outside. So I'm gonna make it a reference, and I'm gonna, yeah, I will be putting it here, number of events. Yeah, number of events is 0. Maybe I should also make sure that, yeah, to set it to 0 also here. Yeah, oops. Oh, Xcode just crashed. Beautiful. And it's showing on my other screen. Okay. Yeah, I can say AsyncKernelEvents dot number of events is 0. No matching function for calling memset. Why? No, this is a private member. Okay, let's do things one by one. Friend struct AsyncEventLoop. Okay. Why there's no matching function to call memset? Some memory is const. Yeah. Is this correct? Yeah. Kernel events POSIX must explicitly initialize new events, of course. So we want to make new events to point at AsyncKernelEvents dot number of events. This implicit conversion is losing, so let's static cast int. Yes, and static cast int also this one. And echo type event incompatible pointers. Const, why am I getting the const version of this one? Oh, okay, that's what I got wrong. The memory should not be const uint, should be just uint. Now it's complaining because I'm assigning a struct k event from unsigned char. Deck type events, yes. Oh, that's why also, so we had to do this cast here. It's not needed at all. Yeah, because I was declaring the memory to be const, which is clearly wrong. Okay, this run looks decent. So we are getting now the events from outside, routing and persisting the number of events in this outside controlled object, and also computing the total number of events that we can store by checking how much memory we have divided by the size of a single event. Yeah, this looks good. Maybe I should also add this line here, and we should be okay. Yeah. Let's try it now to implement the blocking poll. So blocking poll should be doing the second part, which is this one. So we are checking if you can early exit the event loop, run. And then here we need to recreate this kernel events object pointing at the same async kernel event memory. So yeah, something like this. Oh, we need the sync mode. Okay. Sync mode. So we have now to recursively add the sync mode everywhere. Do we need the sync mode also for the runCompletions? No, so it's only for the blocking poll. Let's add the sync mode to blocking poll. Blocking poll. Here we have the sync mode. Yes, of course, this needs to be added in the public API. Blocking poll as well. Oh, sync mode is a well, we don't need to expose the sync mode to the outside. Yeah, we can just do it. Yeah, we will be hard coding the sync mode that forces the forward progress, which is the only thing that is really interesting, I guess, for the common use of something like that, where you really want to be blocking the event loop in like a background thread, as we will be seeing maybe in a future video. Okay, we have the sync mode, and now I need to run the completion. So the completion is everything ranging from the timers to the manual thread pool completions. So yeah, let's copy them. And so also here we need the kernel events object, and I'm going to create it. We have async kernel events. Okay, this is compiling, which is encouraging. So I guess one thing I could try to do is to re-implement the runStep in terms of these three functions to see if the test suite is even running. So let's say I'm calling submitRequests, yeah, with my AsyncKernelEvents, which I still need to initialize, but we will do it in a minute. I can call the blockingPoll using the sync mode that I have been given. And I can call the runCompletions. So this is only like a very glorified refactoring, I guess, but you know, just to show the type of things being done on a project like this, maybe it's interesting. So yeah, of course we need to SC try all of these, which means checking if any of these functions is failing, and if it fails, just return the control to the caller, similar to an exception, but without exceptions if you want. So AsyncKernel memory, AsyncKernelEvents memory now. Okay, so now we need like a buffer. I will do uint 8 like events buffer. Can we make it, I don't know, 8 kilobytes? Yeah, 8 kilobytes. So this can be our events buffer. Yeah, this looks decent. Let's try to run something. Shall we just try to run the entire suite of tests? I guess this will crash, but why not? Let's try it. This is not crashing. That's not possible. Well, this was easy, probably just splitting a function in 3 functions. So yeah, that's what I wanted to do. I guess this makes, I mean, should we be going forward or not with this video? Yeah, probably I'm going to stop the video now and yeah, maybe create another video where I'm using maybe a slightly cleaned up version of this one, also by testing it on the other platforms, because so far this has only been implemented into the Async POSIX backend. But you know, the very same action can be done on the Windows backend, on the IOU ring backend. So I suspect it will just be very repetitive to do, so not very interesting to show. So yeah, with these 3 building blocks, we will be able to construct another class that will allow us to run all of these event loop requests and completions in the specific threads we need in order to integrate it with another event loop. I hope you enjoyed the video and you have been finding it useful. So please join the Discord if you would like to get in touch, or just write something in the GitHub, open some issue, open a pull request if you feel like you have something you would like to be sharing. And see you for the next video. Bye.